Good morning, my dear students. This is Manish Sir, and you are watching your favorite YouTube channel, that is Manish Physics. So, children, all the examinations of the last academic session is completed, finished, right? Starting from the board examination, right? IIT-JEE main, then JEE advanced, and finally the NEET examination, right, children? Many of you have secured the good mark, so few of you, or I mean to say many of you, also want to try to secure even the better marks, right? Many of you have taken the admission in different engineering colleges, so many of you try to take 1 year drop, right, children? So children, this video is for those who is continuing the class 12 science in this year, and those who want to take 1 year drop, right, children? So this is very helpful video. So let us start this video. Okay, so the topic name is electric charge and field. Okay, children? So children, you know my punchline. What is the punchline? Build it right and build it once, right, children? If you build something very constructively, you need not have to build or rebuild the same thing multiple times, right, children? So what I mean to say, involve yourself, okay, from day one, children. Open your copy, take your pen, I mean keep your pen with you, and try to make the notes whatever we are studying here, right, children? Involve yourself. So come and let us start the chapter, very first chapter, children. Okay, that is electric charge and field. Okay, children, this is the first chapter, chapter number 1 of class 12. Okay, this is very important for JEE main and NEET examination as well. Okay, children, clear? So let us start the chapter. Okay, so children, first you write the electric charge. Okay, we will start with the electric charge. Okay, children, so give the topic name is electric charge. Okay, so let us talk about first charge. Okay, children, you see, the electric charge is the very fundamental entity of any body. Okay, children, what I mean to say, just see, if you take a comb, okay, and try to pass it through in a dry hair, and then you take that comb, okay, near a very tiny object like a piece of paper, you will find that piece of paper is being attracted. Okay, why does this happen? Because the comb, okay, it is electrified. I mean to say, it acquires some charges, okay, and that charges is try to attract or pull the a very tiny object like a piece of paper, very small piece of paper, children, right? So you first write the definition, children. What is the electric charge? Right definition: it is an intrinsic property. Right on, children, huh? It is an intrinsic property of elementary particle of matter, of elementary particle of matter. Okay, children, elementary particle of matter, which gives rise to electric force between, which gives rise to electric force between the charges. Okay, children, between the various object, between the various object. Okay, children. Okay, so please note down, it is an intrinsic property of elementary particle of matter which gives rise to electric force between the various object. Okay, children, so it is it is the definition of charge. Okay, children, now let us come to from where the concept of charge comes, right, children? From where the concept of charge comes into place, children. See, I will go little, this particular video is little theoretically, right, children? Then we will go to the conceptual. Okay, so you first find, children, how many different types of charges are there, and how does those charges comes into play? How do we identify, how do we understand that there are only two different types of charges? Okay, children, so name the topic, two kinds of electric charges. Children, name the topic, two kinds of electric charges, as we all know, right children, as we all know, one is positive charge, one is negative charge. But was this, I mean, from the beginning, are we calling it as positive or negative charge? So the answer is absolutely no. Okay, very later we have said that this is a positive or negative charge, but initially what do we call it? Okay, let us understand it well. Okay, so children, let us go for different types of experiment. How do we identify there are different types of charges, particularly two types of charges? Okay children, so let me explain the experiment number one. What is the experiment number one, children? So what happens, a glass rod has been taken. Okay children, this is a glass rod. Okay, what is this? This is a glass rod. Okay, and this glass rod is what, rubbed with the, I can say, silk. Okay children, understood? Let us assume this is a glass rod. Okay, I have a silk, okay, the cloth, okay, and try to rub it. So during the rub, I mean, if I rub two substances, what happens? Electron transformation takes place, right children? So what happens, take a glass rod, in short I have written the GR, and you see, try to rub this glass rod by means of a silk. Okay, and suspend this glass rod, okay, by a rigid support. Okay children, so this is also, I can say, silk. Okay, this is the glass rod. So obviously it will develop one kind of charges. Say yes or no, all of you, right? See children, once I will rub the, okay, the glass rod by the silk, I will find that this glass rod acquire what, some kind of charges. Now again the same thing. Okay, another glass rod, okay, that is also, okay, that is also, you see, rubbed by the silk and then suspended by a rigid support. This is the glass rod. Understood children? So obviously, see, this is one glass rod, this is another glass rod, and both the glass rod has been, what children, rubbed with the silk. So obviously they will what, generate the same kind of charges. Okay, and if you bring them together, I mean to say, both the glass rod are they placed together or near to each other, you will find there is a I mean, both the glass rod try to repel each other. Is that clear? Okay, because obviously this is one glass rod, this is another glass rod, both the wire are nothing but the silk wire. Okay, so both will generate the same amount of, I mean, not same amount, sorry, similar charges, right children? Okay, this is one experiment. Now what you do children, you take this is, I mean, one part, you take a plastic rod. Okay children, this is what, a plastic rod. Understood children? This is what, a plastic rod, in short I'm writing. Okay, and the plastic rod is rubbed with wool. You know the wool, yes or no children? The plastic rod is rubbed with wool, and this plastic rod, this one, this one is suspended by the means of rigid support. Okay children, so obviously this was the glass rod and the glass rod was rubbed with the silk. This is the plastic rod and the plastic rod is rubbed with wool. So plastic rod will also generate some, I mean, one different kinds of charges, obviously, other than the glass rod. Say yes or no, all of you, right? So you will see, when you bring, you see, the two plastic rod in the similar manner. Children, understood now? The two plastic rod, one more plastic rod, if I bring in the similar manner, okay, rubbed with the, what children, wool. Okay, then you will find there is again a force of repulsion between the two plastic rods. Okay, this is also a plastic rod. Understood children? So why they are repelling each other? Obviously the two rods are the plastic rods and they are again rubbed with the similar kinds of material like the wool. Okay, these two glass rods are being rubbed with the similar material called silk. So this will generate one type of charge and this will also generate the one type of charge, but both the type of charge in this case is same and here also in this case is similar. Is that clear? So here the glass rod repel each other, here the, what children, the plastic rod is also repel each other. Understood children, right? But when I place one glass rod and one plastic rod, let us assume here one plastic rod children, let us place another plastic rod here. Okay, you understood the children, right? A plastic rod, I place it here near the glass rod. Understood? Okay, so children, so what will happen? So nothing will happen, nothing will happen. Obviously there will be something happen, right children? So this is the silk and this is, I can say, wool, right? So you will see here, children, both the glass, I mean, this is glass rod and this plastic rod. Now there will be a attraction between the glass rod and the plastic rod. Now children, see, I understood this is a particularly theory. Why sir you are teaching so much in detail? Children, just to understand, right? Okay, so you see from here the two glass rod is being rubbed with the silk, they generate one kind of charge. The two plastic rod, I mean to say the plastic rod is rubbed with the wool, they will generate the another kinds of charge, right? When two similar charge are bringing together, whether let it be positive, this means negative, for example. So positive will repel, negative also repel. Now I find here this is positive, this one is negative, so they will attract. So from here children, this is one experiment. From this experiment we understood there are two different types of charges. Understood children? Everyone say yes or no. Please write down in the comment box if you understood or not. Okay children, now let us go to the next experiment. Please pause the video and try to make your note, children. Okay, your note, your involvement will help you. Trust me children, I'm telling you, trust me, your involvement is the cause of your development, right? Okay children, now one more experiment. Let us do one more experiment children, right? What is that experiment children? Let us take two pith ball. Okay, two pith ball, small, you know what is pith ball children? Okay, two pith ball, right children? Now you find, let us touch, I mean one pith ball, that is, this is A, this one is B. Now the pith ball A is touched by the glass rod. Okay, so glass rod will develop one kind of charge on A. Obviously, let that charge is positive. Is that clear? Right? Okay, children. And if the plastic rod, which is obviously charged, when touched to the second ball B, okay, it developed the another type of charge. Let that charge is negative. Okay children, so you will find there will be this, both the what, the ball is attract each other, right children? Both the balls attracts each other, there will be a force of attraction, right children? But okay, what happens now? Let us assume this is a glass rod, I mean pith ball A, this is also pith ball A, or you can say this is also pith ball B. Now this pith ball is charged by the glass rod, this also by the glass rod. Okay, so obviously this will generate a positive charge, this will generate a positive charge. So how do you know that there is the positive charge? I am considering it, right? Let us assume that, right children? So here the two pith ball will repel each other. Is that clear children? Again, if I say, okay, two plastic ball, now this is plastic ball, I mean sorry, not plastic ball children, pith ball, let this is A, this is B, and both are charged, okay, by the plastic rod. Okay, so for example, plastic ball rod will develop the negative charge, so this will be negative, this will be negative. I can say both are repel each other, right children? So from these two experiment we find that, okay, what do we find? We find similar charges repel each other, children, very important, right? And these similar charges attract each other. Clear children? Attract each other. Is that clear children? Okay, so from this two experiment we found that how many kinds of charges? There are two different kinds of charges. What are two different types of charges? One is, I can say, charge developed by rubbing the glass rod with wool, glass rod with silk, and the plastic rod with wool. So obviously the charge developed on the body is different. So if you place the different charges together, they will attract. If we place the similar charges together, they will repel. Understood children? So from this two experiment we found that there are how many types of charges? Two types of charges. Understood children? Understood? So children, you should I mean there is no need of remembering all this, because these are not at all coming in the examination, right children? This is only to know how the concept of charge comes into play, right children? Okay, but you see, you know, we are calling it as positive or negative charges, but you see initially, okay, initially the charges was known as vitreous and resinous charges. Okay children, you please write vitreous, 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 and resinous, resinous, resinous charges. Okay, children. So see, initially, the charges was not known as the positive or negative charges. Okay, it was vitreous and because of the resin, children. Right? If you say, children, the word vertum. Okay. See the word vertum. VRUTUM. Okay, it means glass. Okay, it means what, children? That is glass. Okay, right? And you see I mean amber plastic rod. Okay, rod with wool, it will generate one type of charge, na. So amber means what, children? Amber is a resin. So from vertum, this is vitreous charges. From resin, this is resinous charges. Understood, children? But see, while writing all these charges multiple time, every time we have to write vitreous and resinous. Okay, this is quite, you see, complex, right? So in order to avoid this complexity, we are replacing these charges by positive or negative charges. Understood, children? Yes or no? Okay, so the glass, the glass rod, or I can say vitreous, is positive, while the resinous is considered to be a negative charges. Understood? So this is all about the children. What I mean, how the charge comes into play, how many different types of charges, charge definition. Similar charges repel each other, while dissimilar charges attract each other. Right, children? Hope you guys understood it clearly. Right, children? So let us write the very important thing is the basic property of charge. Write down, the children. What is that? Basic properties, not property, properties of electric charge. I'm writing in short form, children, because I don't have much place to write. You see, I have very limited space here to write down. Okay, children? So you don't write the small, I mean to say the short form. You write electric charge. Somebody might say this is election commission, sir. No, this is not the election commission. This is what the electric charge. Hope you understood, children, right? So what are the basic property? So children, first, you see, it is a charge is a scalar quantity. Children? It is a scalar quantity. And I know, children, you know what do you mean by scalar quantity? Yes or no? Children, you know that what is scalar quantity? The quantity which has only magnitude is what known as the scalar quantity. Second property, children, since it is a scalar quantity, it can added what, children? Algebraically. It can added what, children? Algebraically. For example, okay, children, it's given q1 equal to 5 coulomb. Since we have not talked about the unit of charge, after that I will talk about the unit of charge, children. Okay, q1 equal to 5 coulomb and q2 is equal to, let it is minus 3 coulomb. Okay, add them. So q is equal to q1 plus q2. Okay, so q1 is 5 coulomb plus this is minus 3 coulomb. This is nothing but 2 coulomb. Understood, children? Clear? Okay, so it can added algebraically. Second property. Okay, third, I can say, children, a very, very, very important property is what? Charge is quantized. Clear, children? Charge is what, children? Quantized. Okay, so children, let us discuss about the quantization of charges. Okay, that is very important and the basic property, children. You know, you should understood it well, right, children? Children, you know it very well, right? You have to understand something. Okay, and then somewhere where you find that this should be very important, you need to remember it for the long time, right, children? Okay, so you will see charge is quantized. Children, let us talk about the neutral body. See the pen, this marker in my hand. You tell me, children, it is a charged body or a neutral body? Okay, you may call it's an insulator. That's a different thing. We will discuss about the conductor and insulator later, not today or in this video, right, children? So what happens, children? A neutral body. Okay, if I'm talking about a neutral body, this is body A, which is a neutral. These are the body B, which is also a neutral. There are two different body A and B, and both are neutral. Right, children? So neutral body means it doesn't have, it doesn't mean it doesn't have charges. It have charges, but the number of electrons and protons both are same. Okay, children, understood now? Children, here the electron and proton in both the body are same. Now what I mean to say, I want to transfer some charge from body A to body B. How will I transfer the charge, children? Can anyone tell me? Yes, children, can anyone tell me how do I? Obviously, I have to rub the body, right, children? We have already discussed about how the body is getting charged just by rubbing Children, we have taken an experiment, right? We have done an experiment, right? Glass rod is rubbed with the what? Silk, and plastic rod is rubbed with the wool. Is that clear, children? So by rubbing the body, okay, let us transfer few electrons. Okay, children, few electrons is being transferred from body A to body B, right, children? See, children, electron is negatively charged particle. You know it very well, right, children? And what is the magnitude of charge? That is minus 1.6 into 10 to the power minus 19 coulomb. This is what the charge on an electron, right, children? So why the negative charge body? Why the negative sign? Because of the it's a negative charge particle, right, children? So let us assume I want to transfer, for example 2.5 electrons from body A to body 2. Will I do that, children? Can I do this? Can I do this? So the answer is of course no. Why no? The question is why we cannot transfer 2.5 electron. Listen to me, children. Because the electron is the smallest particle, right, children? Electron is the smallest particle of the universe, right? So if it is the smallest particle, can you break the smallest particle? Of course not. And if you can able to break the smallest particle, then is it a smallest particle ever? So the answer is no. So that is why, children, remember, you can write a note. Okay, since electron is a smallest particle, right, children? Smallest entity or particle of the world, so it cannot be divided, okay, or it cannot be break. Okay, children? So fractional charges cannot transfer. Remember, children, right, children? So I mean to say, this is 2.5 electron. This cannot be transferred, right? But we can transfer 1 electron, 2 electron, 10 electron, 1000 electron, 10,000, 1 lakh, 2 lakh, any amount, but it should be integer. So children, Q is directly proportional to E, and Q is equal to N into E. This is the property called quantization of charge. Understood, children? Q is equal to N into E is the property which is very, very, very important. That is quantization of charge. Understood, children? The fractional charge will not be transferred. Why? Because the electron is so, is the smallest particle of this universe, right? And Q is equal to N into E. So what is N, children? I can write where N is equal to plus minus 1, plus minus 2, plus minus 3, dot, dot, dot. Understood, children? Right? So here is one question, children. Okay, please, children, pause the video and try to write all the thing whatever I'm writing in the board, children. See, as I'm saying from the very beginning, your involvement is the root cause which can take you from anywhere to anywhere you want to go. Children, see one thing: nowhere. This is the spelling, right? Okay, if you just be committed, okay, from the beginning, you can be now here. Is that clear? Nowhere is transferred to now here. Now here means your goal, your destination, right, children? Okay, so children, the question, you write one question: find out the number of electron, right, children? Find out the number of electron 1 coulomb charge has. Okay, children? So 1 coulomb charge has how many number of electrons? So very easy, children. See, Q is given 1 coulomb. I will discuss you, children. Coulomb is the SI unit of charge. Once I complete the property of charge, I will come back to what? The unit of charges, both the SI and CGS unit of charges. Okay, children? So Q is given 1 coulomb, and we know that Q is equal to N into E. Right? So the question is N is Q by E. So Q is 1 and E is 1.6 10 to the power minus 19 coulomb. You may ask me, sir, you have said charge is negative. Baba, that's polarity. Okay. The charge, electron is negatively charged particle, proton is positively charged particle. So in order to explain, to understand it's a negative charge particle, we are writing negative. But what is the magnitude? This is the magnitude, right, children? So you do one thing, children, that is 1 by 1.6, that will be 10 to the power plus 19. Say yes or no. Then multiply 10, both the numerator and denominator. Okay, so you will get here 10 by 16 and 110 from here, that will be 10 to the power 18, right, children? If you find, that will be 6.25 into 10 to the power 18. So just imagine, children, right? 1 coulomb charge has these many electrons. Understood, children? This is a very important question. I mean, not very important, children, but you see, this is the very basic question, right? Okay, hope you understood this question, right, children? So let us proceed further. And the last property, children, of the charge, last property, what? Charge is conserved, right, children? Right? Charge is conserved, children. In an isolated system, the total charge remains constant. And you know the conservation of energy, do you? You know the conservation of energy? Say yes or no, all of you, right, children? How you I mean, children, in the early classes you might have known that what is that? I mean, the energy neither created nor destroyed. It can transfer from one form to another form and all this, right, children? Here also, charge can neither be created nor be destroyed. It can only transfer from one form, one body to another body, not one form to another form, rather one body to another body. Understood, children? So let us assume this is, I mean, but children, one thing I must tell you, the body must be isolated. Okay, for example, children, see, let us assume this is one isolated body system. Okay, there are three bodies in this here, just sir, this is just like a monkey. Okay, let this is body A, this is body B, this is body C. Okay, children, let us assume here plus 5 coulomb, here minus 9 coulomb, here plus 10 coulomb. So what is the net charge of this body, children? You can say 10 plus 5 is 15 minus 9 is 6 coulomb, right, children? And the same isolated system, I have replaced the body. Okay, I mean to say, let the same, I mean D, E, F, right, children? Now the same isolated system, just I change the name of the body, right, children? Let us assume here this is 10 coulomb given. Let this is 6 coulomb, this is 7 coulomb, and let this is x coulomb. Okay, find the value of x. So what do we know, children? We know that in an isolated system the total charge remains constant. So here total charge is 10 plus 5, 15 minus 9 is 6 coulomb, and here is x plus 6 plus 7. So children, x plus, what is 6 plus 7, children? That is 13, right? 6 plus 7 is 13, equal to 6 coulomb, right, children? So what is x is equal to 6 minus 13 coulomb. Are yaar, yes or no, all of you? Understood? So this is what, actually minus 7 coulomb. Okay, so the answer is x equal to how much? Minus 7 coulomb. Understood, children? So in an isolated system, the total charge remains constant. Okay, and charge can be transferred only from one body to another body. Okay, children, remember? So these are the 4 different properties of charges. Okay, now come to, children, what are the, I mean, property of charges we have done. Now let us find out what are the units of charges. Okay, children? So right, children, already we have discussed charge is a scalar quantity. Okay, children? So SI unit, children, remember the SI unit of charge is coulomb, COULOMB. Okay, and we are writing capital C. Understood, children? We are writing what, children? Capital C for coulomb. Understood? Very important, children. Understood, everyone? Okay, so this is the SI unit. Now let us come to CGS unit, children. So please write the CGS unit is electrostatic unit. In electrostatic unit, ESU. Okay, children, the CGS unit of charge is stat coulomb. Remember, children, SAUCOULOMB. Okay, children, what is the CGS unit of you see the coulomb, I mean the charge in ESU system, I mean to say electrostatic unit system. Okay, so remember, children, 1 coulomb is equal to, remember, 3 into 10 to the power 9 stat coulomb. Clear, children? That you should remember. Okay, 1 coulomb is how much? This is the electrostatic unit. In electrostatic unit, the CGS system, okay, the CGS system of unit of charge is stat coulomb. Okay, children? And in magnetic electromagnetic unit, children, it was ESU, now EMU, electromagnetic unit, the CGS unit of charge, I can say ab coulomb. Okay, children, what is that? Ab coulomb. So 1 coulomb is equal to 1 by 10 ab coulomb. Is that clear, children? Okay, so this is basically about what? This is the what? Unit of charges. Understood, children? SI unit is what? Coulomb. The electrostatic unit is what? Stat coulomb. 1 coulomb is equal to 3 10 to the power 9 stat coulomb. Stat coulomb is the CGS unit, okay, of the coulomb, right? But in electromagnetic unit, the CGS unit of charge is amp coulomb. So 1 coulomb is equal to 1 by 10 amp coulomb. Understood, children? So these are the charge, about the property, and scalar or vector, or I mean to say what how the charge comes into play, and everything about the charge. Children, one thing you find here we are studying about the thing like charge, okay? Basically charge, we are talking about the electron, right, children? So here we are talking about the electron or the charge of electron, or we read the entire chapter. Not only this chapter, there are so many further chapter, okay? So the basic thing is what? The electron, right, children? But we can't see electron. That's the main difficulty, children, okay? So that is why here the imagination comes into play, right, children? Okay, we have not seen the electron at all, but we know everything about the electron. What is the charge, what is the mass, and everything, okay? Negative charge particle and all this, right, children? Further classes you will find this all thing. Gradually it will be clear to all of you, right, children? So this is all about the charge, children. Then let us find out the comparison between the electric charge and mass. Write down, children. Comparison, all of you please write down the comparison between electric charge and mass. Okay, children, this is short form of electric charge. Okay, now make a 2 column, children. 2 column. In 1 column electric charge, in 1 column this is mass. Okay, see, children, very easy. Okay, let me tell you one thing. First electric charge can be positive, it can be negative, it can be zero, okay? But mass, children, always positive or zero. Okay, children, mass may be zero, okay, right? Very less mark, less mass, okay? So that is why zero mass has nothing, no meaning, children. There may be some slight mass. Let for example the mass of electron. How much this is? 9.31 into 10 to the power minus 31. If I talk about the electron, children, it has mass 9.31, 10 to the power minus 31 kg. See, minus 31 kg. Still it has some mass. So it's better. Don't write the zero mass. Okay. It's always what, children? Positive. Understood, children? Right? Yes or no? Now, second, charge is quantized. Q equal to NE. Okay, children? No such kind of thing about the mass, children. Okay. No such kind of thing about the mass. Clear, all of you? Let's drink some water, children. It's too much hot here in this room, right? Anyway, we are so much excited about our dream, right, children? Okay. So, your next, right? Children, charge is strictly conserved. Charge is strictly conserved. Remember, strictly. But children, mass is not strictly conserved because some mass is converted into energy, right, children? Some mass is converted into energy. That you should remember. Okay, children? Right, now it does not depends upon the speed, it depends upon the speed, children, relative speed, right? So m is equal to m0 whole divided by 1 minus b square by c square, right, children? Okay, this is the see, m0 is the rest mass. What is m0? That is nothing but the rest mass. Okay, children. What is b? Is the speed of the particle in that medium, and what is c? Is the speed of light, that you know it very well, right, children? So here the force comes into place, electrostatic force of either attraction or repulsion. Children, electrostatic force of either attraction or repulsion. Children, I don't have much space to write, my dear students. Okay, that is why I'm trying to write in the so short form, but you please don't you write the short form, right? Write the complete sentence, right? Electrostatic force of attraction or repulsion between the charges, okay? And between the masses, there is gravitational force, right, children? Gravitational force of only attraction. There will be no gravitational repulsive force. Right, children? So this is the comparison between the what, children? And one more thing, children. See, every charged body has a mass, children. Okay, this is very important point. Every charged body has a mass, but every mass may or may not have charge. For example, if that mass is insulator, understood children? For example, that mass is insulator, then insulator do not have any charges, right? So every charged body, for example electron, so what is the mass of electron? This one is the mass of electron, however small the mass may be. Children, you understood now? However small the mass of electron may be, but it has some mass, right? So every charged body has mass, but every mass may or may not have charges. Clear children? You can write every charged body has some mass, but every mass may or may not have charges. Understood children? So please children, just pause the video and try to write all these things, right children? That is very, very, very important. What is very, very, very important? What is your involvement? Right children, from the day one, if you involve well, trust me children, you will perform well in your life, in your examination. You don't have much time children. The very next year, January, 25th to 31, the JEE exam will start, right? So you don't have much time to waste. You see, that is why you start preparing from the day one, right children? Okay, so this is all about the charge. So बच्चों, अगर तुम्हें ये वीडियो पसंद आया है तो इस वीडियो को लाइक करो, सब्सक्राइब करो और इसको धड़ल्ले से शेयर करो। ठीक है बच्चों, तुम्हारा एक लाइक, तुम्हारा एक सब्सक्रिप्शन, भले ये तुम्हारे लिए कोई बड़ी बात ना हो, ठीक है, लेकिन बच्चों ये मुझे बहुत ही बूस्ट देगा। ठीक है बच्चों, मैं एक छोटे से शहर से आकर के वीडियो बना रहा हूं, सो मुझे उम्मीद है कि एक ना एक दिन ये वीडियो हिंदुस्तान के सभी कोनों में देखी जाएगी, है ना बच्चों? ठीक है, मिलते हैं एक और शानदार वीडियो में, तब तक के लिए थैंक यू, गॉड ब्लेस यू।